Greetings, I'm Professor Hobo, and welcome to another HOBOTECH product review. So riddle me this, what's orange and black, has a large fixed handle, and a 300 watt-hour battery? It's not what you think. It's the AUDEW 300 watt-hour lithium iron phosphate portable power station. We're here to find out, is this thing any good? Let's check it out. So what comes in the box? Well, we have the AC wall charger, 60 watts. We have the 12 volt car charger, so you can charge it from a vehicle. Of course, they give you an MC4 connector, so you can actually hook up a solar panel of your choice to the AUDEW, and they give you a pair of jumper cables. Yes, because this actually has a jumper port on it, so this plugs in, goes directly to the battery and the AUDEW, and allows you to jump start your car. And of course, they give you a little tiny manual. Oh, isn't this little manual so cute? It's even in color. But there's nothing special about this manual. They don't really give you anything out of the ordinary kind of information. If you want the statistics in metric, there you go. And if you want to know all the statistics on one page, there you go. Yes, this says device work when you turn it on. And it really just goes into telling you what it comes with and then the environment working conditions. Now, do note that this does say it does operate, meaning charge, from 0 to 40 degrees centigrade. So that's typical for a lithium battery. It does say you can store it down to minus 20 centigrade and up to 85 Celsius. Wow. I find that pretty funny how it says that the altitude can be 2,000 meters. Well, where I'm at right now, it's over 2,000 meters and it works just fine. Product attentions. Be carefully to move it when handling strenuous vibration, shocking, extrusion, and exposing, and the sun and rain is prohibited during vehicle, train, vessel, and aircraft transportation. Do make note of that. So what can the AUDEW do? And how many times can I successfully use that pun in this video? Well, for starters, it has that 10-year lifespan lithium iron phosphate battery rated 2,000 cycles to 80% capacity. That doesn't mean after 2,000 cycles you just throw it out the window. No, that means you only lose the top 20% of the battery capacity. You still have the 80% remaining after that 2,000 cycles. That's why I say this will last most people anyway, at least 10 years, if not much longer than that, depending on how you use it, how you store it, temperature range, how fast you charge and discharge it. There's a lot of factors in battery cycles, so what you get from a manufacturer is usually pretty conservative. As for size and weight, this is 12 by 8 by 9 and weighs just under 12 pounds. As for build quality, it is all ABS plastic. It does have some little stick-on rubber feet. As for the design of the display, it has one of those very basic 5 battery icon displays, which just shows you a generic representation of the battery charge. This does not show you input or output wattage or anything like that. Now, as for the inverter size, it is toggled with this little toggle switch here. You turn the inverter on and off through there. It has these 2 international style outlets, which means you can plug it in different countries. Supports up to 250 watts, and it is pure sine wave. Now, they do claim this has an MPPT solar controller built in. We're gonna obviously test that in a little bit. There's some interesting results there. So how does the AUDEW do when it comes to charging speed? Well, the factory wall outlet is 60 watts and can charge this in about 7 hours. The included MC4 adapter allows you to charge it from a solar panel in somewhere between 6 and 8 hours typically, but I have some more information on that after my testing. And 12 volt vehicle, you'll charge typically in about 8 hours. As for 12 volt outputs on this, it does have a 12 volt cigarette lighter output rated at 10 amps, and it does have a jump starter port on this. Now, they say it is good for 1,000 amps, but when they say 1,000 amps, they actually mean 1,000 cold cranking amps, which is kind of different than actual amps. You can't expect to pull 12,000 watts out of this port, and of course we're going to test this here in a bit. I'll get this open one of these days. There we go. As for USB outputs, you do have 2 USB-A QC ports rated at 24 watts, and you also have 2 USB-C ports rated at 12 volts, 2¼ amps for a max of 27 watts. Now, as for the jump starter port, this is a little different. It does come with these clamps, and this plugs in here, and it only plugs in one way, so you can't get it backwards. And obviously you put the red to the positive on your battery and the negative to a ground on your car. Now they say this supports up to 4-liter gas engines or 3.5-liter diesel engines. As for other features, it of course has a lantern style flashlight on the side hidden by this cool little door. And one other thing that's very interesting, this is the first portable power station I've ever reviewed that has no fans, so it's entirely silent. In fact, if you notice, there are no vents in this whatsoever. So whatever heat is inside of this is going to stay inside of this. And that's a positive and a negative. If you're a person that hates noise and hates fans, this is probably the only power station you're going to find on the market of this size that's not going to make any noise whatsoever. And as for the warranty, AUDEW does 12-month manufacturer warranty on this. So what did I do with the AUDEW in my secret laboratory? Let's find out. This is the AUDEW portable power station, starting voltage 13.7. Here we have the results of the AUDEW 310 watt hours, 25.4 amp hours, total discharge time 3 hours, 5 minutes. So very interesting results from the battery capacity test. 310 watt hours out of a 300 watt hour battery? How can you get 103% out of a battery? Well, it's overrated. They obviously tell you it's a 300 watt hour battery, but it's probably somewhat larger than that, maybe 330, 340 if you add up all the watt hours inside of the batteries. Now, if you remember, this also reserves the bottom 10% of the battery so it doesn't over discharge it. Now, how do I know that? Because when this is fully discharged, it goes down to 12 volts. If they allowed you to fully discharge a lithium iron phosphate, it would go down to 10 volts. 12 volts reserve somewhere around 10% of the battery. So it's very obvious that they underrated what's in here. That probably explains why it's a little bit larger and heavier than you think it should be for 300 watt hours. And since this is a lithium iron phosphate battery without a voltage regulator in it, that's not wasting any power. So you're not losing any of that power to heat while you're using a 12 volt system like you would with all the other power stations that have regulated 12 volt circuitry. This means overall you get about 12% more capacity out of this than you would a Jackery Explorer 300. Now let's check out the DC output rate check. This determines how much power you can pull out of the 12 volt socket. One of the things I do like about the AUDEW is this power button. It's nice and solid. It feels like it's a metal switch. So when you click it, it's got a nice physical feel to it. It's not just one of those little plastic push buttons. You know, for this, you need to actually hold it down for a second. And then it'll say device work, and you know it's ready to go. So I already have this set up for the start at 10 amps. We know the AUDEW can do 10 amps. Let's go ahead and push it to 11. Just like a good Marshall stack, you push it to 11. We're still pulling 12 volts, 11 amps, no problem, 133 watts. Let's go ahead and keep increasing it, 11 and a half. Oh, okay, it looks like it drops out right around 12 amps. You can see on there it says device alarm and it's showing 12 volt blinking. And in order to reset this, you got to turn it off and back on again.
Hello, IT? Have you tried turning it off and on again?
So that's pretty typical. 10 to 11 amps is about right for a socket like this. We're here testing the AUDEW jump starter port. Now, this is unique. Not a lot of power stations nowadays have jump starter ports on them. This one, they say, is rated for 1,000 amps, but you know that's absolutely not going to happen. They're saying you can use it as a 1,000 cold cranking amps jump starter. So I have no way to test one of these because I don't have a car laying around with a dead battery in it. So what I'm going to do instead is I'm going to use this little meter here and we're going to just run a load on it. We're going to see how far can we push it, how many watts, how many amps, until the AUDEW shuts down. So for this test, we're going to use the solar degenerator, but we have no way to blow up the AUDEW because we're doing this through the jump starter port. We're not doing it through the inverter. So let me describe real quick how we're setting up this test. So I have coming out from the jump starter port these wires that's going to this shunt, and this shunt is going to this meter, which is right here, and it's going to tell us how many watts, how many amps we're pulling. We're using as a load this BESTECH 1200 watt inverter. And on this side of the inverter, we have this meter, which will tell us how many watts we're pulling out of the inverter, because for whatever reason, this inverter, the meter on it doesn't work right if you're putting a resistive load on it like a hairdryer or heat gun. It shows much lower wattage than what's coming out. So we're just going to verify the numbers by using this meter. Here we go. Test number 1 with a solar degenerator. We're going to use the lowest power setting, lowest heat setting possible. We'll start low and we'll work our way up until it shuts down. 200, 230, 250. You can hear it slowing down, meaning it's stressing the inverter. We're at 300. 350. 400. And this is coming from DC. Okay, so I cannot turn it up any higher on the low setting. We're going to have to go to the high setting. Okay, 400. 450. 500, 550, 600, and that's it. So let me explain what just happened there. Once we got over 600 watts, it was pulling too much from the AUDEW. In other words, the voltage dropped too low to be able to power the solar degenerator any further. So you can expect a maximum of 600 to 700 watts out of the jump starter port. Now that's more than sufficient to start a small vehicle if you have a dead battery, because you're not starting it directly from the AUDEW. The AUDEW is sort of setting a pre-charge to your starter battery in your vehicle, and then that assistance is what allows you to start your vehicle. I wouldn't suggest pulling too much power out of this port for a very long time. It is designed to do, they say 1,000 amps, but as you just saw, that's somewhere around 50 amps. I wouldn't do that on a very long-term consistent basis, but you can absolutely pull DC power out. And the AUDEW doesn't even need to be turned on to get power to the jump starter port. So this is a direct connection to the lithium batteries inside. And these are lithium iron phosphate, so they do run a higher voltage. The battery is still running at 13 volts. Now, this thing is mostly discharged down to probably about 40%. We're still getting 13 volts out of this, so it's not regulated. 13 volts is very usable for anything you might want to need, and now knowing you can pull 500, 600 watts out of this, it's pretty amazing. I could see a lot of you hardwiring this into your van or your RV to power stuff. You can totally do that from this port. So I would say you could probably safely pull about 500 watts out of the jumper port. Now that's a direct connection to the battery. It does stay on whether or not you have the switch turned on or not, so keep that in mind. Now, as mentioned, none of the 12 volt on this has a regulation circuitry. That means as the battery drains, the voltage goes down. However, that's not a problem with lithium iron phosphate because the top voltage of this is 13.6 and the fully drained voltage is 12.0. That means no matter what, you're not going to have any issues running your 12 volt appliances like your 12 volt refrigerator or your CPAP machine. They'll run perfectly fine off the 12 volts in this all the way down to the time this thing shuts down. We're now going to do the pure sine wave check under load. As you can see, this is a pure sine inverter. You do have a pure sine wave, and we're going to go ahead and use this hairdryer with no heat on low. The inverter in this is pretty weak, so we can't even apply any kind of heat or anything to this, but let's watch the sine wave. Still looks pretty good. So we've under load, you still have a pure sine. Inverter capacity test. I'm using this as the load. So I have the inverter powering the charger, which is variable voltage, charging the Blue Eddy. So we can get a very accurate assessment as to how many watts we can pull out of this thing without using the solar degenerator hair dryer, which could possibly damage this inverter. Now we're going to start at 18 volts, and that's the minimum required for the Blue Eddy's MPPT to kick in. So we're currently we're using 155 watts, and we're charging at 124 watts. So let's bump it up to 19 volts, and it shuts down. Okay, so we're able to pull 183 watts. If I try to go anything above that, try to go slightly higher, it conks out, so it's not accepting in more than about 185 watts. All right, let's try the hair dryer with no heat and see if that will do any better. Nothing. So even on the lowest heat setting on low, it sounds like it's gonna fry it if I go any further, so that ain't working. Let's try the solar degenerator anyway, because why not? Okay, solar degenerator, we have no heat on the lowest setting. It's completely failing to power the solar degenerator. This is the volts coming out of the inverter. As I turn up the heat on the solar degenerator, watch the volts. The volts are going down. Wow, I could take it all the way down to 40 volts, 30 volts. I am sure that's going to destroy this thing if I go any further. So what have we learned about the inverter capacity test? The inverter on this is kind of, well, not very good. First of all, it's got a very low wattage. It says it can support 250 watts. I wasn't able to push anything over 200. And at last test, I was only able to pull about 185 before it shuts down. Now, granted, I don't have the battery charged all the way up right now, but this is putting out 13 volts DC, so it should be able to power the inverter with no problem. I can't even power the hair dryer even without heat at all. The solar degenerator, when I crank it up, it drops it all the way down in the dirt, all the way down to 20 or 30 volts AC. And I've never seen anything that ridiculous before. Now, while this might be great for DC, I wouldn't buy this specifically to power AC. Now, you can obviously power a laptop or something very small, very low load on this, but I wouldn't try to put anything of any major importance, any kind of appliance over 150 watts into this, because it's going to drop the voltage. It's just not going to work right. Now, unfortunately, this is one of the few times where the inverter seems to be rated lower than it should be, and I suspect why this is. This is a completely sealed environment. There's no vents, there's no fans, so probably how they're regulating the output on this is by heat. So as soon as you heat up that inverter, it's going to shut down. I was not able to pull 250 watts under any circumstance out of this inverter. I was able to pull consistently about 200 watts without a problem. So I'm going to call this a 200 watt inverter, and I'm going to suspect anybody using this should not try to pull more than 200 watts out of this, because most likely it's not going to happen. Now, that's the upside and downside of the fanless design. It's not going to annoy you with a running fan, but on the other hand, it's a pretty small inverter for something this size. Now, there's one other thing I want to note. Everybody is into lithium iron phosphate batteries. They say that they're way better than lithium ion in all case scenario. Now, here's the downside of lithium iron phosphate. Here's the Jackery Explorer 300, which has a 300 watt hour battery. Here's the AUDEW 300 watt hour battery. This weighs probably twice what this does. And look at the size difference. This thing is significantly bigger. This is almost the size of a Jackery Explorer 500, but it only has 300 watt hours in it. Little tiny 200 watt inverter, where the Jackery Explorer 300, this little thing has a 300 watt inverter. In fact, we were able to push 330 watts out of this without any problem. So lithium iron phosphate isn't always the end all be all. If you're looking for something that's more portable, more lightweight, more power in a smaller package, lithium ion isn't bad. Now, yeah, there's a real big difference in the battery cycles here. This one is rated to 500 cycles to 80%. And this one's rated to 2,000 cycles to 80%. So this one's going to last you a lot longer in time, but the downsides are, again, size and weight. It's excellent for DC. If you don't mind the weight and the size, but you're going all for cycles, this might be a better choice. Okay, here's a very common question that I get on these solar generators. Does this support pass-through charging? Let's go ahead and power it on and find out. So I just turned it on. We have DC power. We have power to the USB ports. And we have power to the inverter. So I have everything turned on right now. Let's go ahead and plug in the default charger.
Well, looky what we have here.
DC power is gone. USB power is gone. AC power is gone. This device does not support pass-through charging on any level. That means while you're charging it, you cannot use it. That goes for AC, solar, DC, any source that comes in here. You can't use it while you charge it. That's going to be a deal breaker for some of you guys. For others, you're not going to care. Now, there is a way around this, and that's to use the jump starter port. It's on all the time, whether you're charging this or not. You can charge this while you use the jump starter port to run 12-volt appliances such as that refrigerator I was just talking about. So it is possible, but you're going to have to do a little bit of engineering. You're going to have to find a plug that fits this socket, and I believe it's SAE. It's probably a standard SAE plug. And you can wire it up to a cigarette lighter or any other way to run a refrigerator, or in other words, if you want to run a CPAP machine, you can probably run it right to that adapter. This next test is the max charge rate test to see how much power can we pump into this from different sources such as solar, 12 volt, and so forth. Now I've already did some testing on this. The very low end baseline, this does not start charging until you have at least 13.2 volts DC. So we're right now at 13.3 and it's charging at 10 watts. Now watch this, this is very interesting. Okay, you can see it's charging around 10 watts, 13.2 volts. Now watch as I increase the voltage on my variable voltage charger. So we're now at 14.3 volts. It's immediately jumped to 125 watts, 15 volts, 170 watts of charging. Now the interesting thing that happens is that no matter how much I turn this up, this is a 48 volt charger. It will not go over 15.2 volts. So I'm assuming that means if you plug a solar panel into this that is anything over 15 volts, it's just going to cap it at 15 volts and get a whopping 170 watts of charging. That is incredibly impressive for a 300 watt hour power station. So on the back of the AUDEW, it says the input is 15 volts at 4 amps. That's only 60 watts. It doesn't say anywhere that this thing can take 170 watts of charging, but I just showed that it can be done. Now the product information for the AUDEW does say that it has an MPPT solar controller built into it, but I've never seen a power station ever act this way before. It hard caps the voltage coming in at 15 volts. As you can see, I was able to charge this at over 170 watts. That's like crazy. I've never seen a 300 watt power station allow you to charge it so fast. Now, I don't know if this is a fluke or if this is by design, but if you can pump enough amps, and up to 12 amps it seems, through this charge port at around 15 to 18 volts, which could be a 200 watt solar panel, you could charge this thing very quickly, like 2 hours very quickly. That's extremely impressive. Now this express charge method is not mentioned anywhere in the book or on the manual or on their website. However, here at HOBOTECH, we don't do things by the book. Now, could you buy several of these and parallel them together for more power? Technically, no, but kind of yes. And this is going to be totally at your own risk. Don't even try to do this if you don't know what you're doing. You could buy multiple of these units and hook them together through this jump starter port because it's a direct connection to the battery. So you could, in parallel, parallel several of these together for more total power through this jump starter port. Now, I haven't tested it, I haven't tried it, but it sounds like it's technically feasible. You're going to have to try it and do it at your own risk. USB output rate check. Verified that the USB-C ports do support 12 volts at 2.25 amps. It's also verified that the USB-A ports do support 12 volts at 2 amps, or 24 watts of quick chargeability. So what do I like about the AUDEW besides the very fun to say name? Well, obviously the lithium iron phosphate battery with its 2,000 plus cycle 10-year life. Feel free to charge and discharge this thing as much as you like. You'll likely break everything else on this before you even wear out the battery. They also underrated the capacity, so you're getting at least 10% more bang for the buck over similar size competition. So what else do I like? The amazing jump starter output on this. Not only can you start your car, but you can easily pull 500 to 600 watts out of this. Could you hook up your own more powerful inverter instead of using the little 200 watt one on this? Absolutely. In fact, that's what I show you in my test. I actually have hooked up a Bestech 1200 watt inverter to the jump starter port, and that's how I was able to pull 600 watts. That also means you can hardwire this DC output to do all kinds of interesting things, like run your max air fan, or put it into a fuse box and have it power lights or other things in your rig. Because you can get pass-through charging on the DC jump starter port on this, you can charge this at 170 watts while you have the output on this running several 12-volt refrigerators. That's a pretty fascinating scenario and something I might even think about trying in the future. So what else do I like? The insanely fast, undocumented charging ability of this. Yeah, 60 watts from the AC outlet, that's dirt slow. But if you get it in the right situation, say that 200 watt solar panel, you could charge 170 watts, and I show you that it's possible. However, don't try to hook solar panels in series on this. You're going to run into trouble if you try to do that. So I'm going to say this again. If you're going to run multiple solar panels in this, put them in parallel only. Do not put them in series because you're very likely to burn out that regulation circuitry on the input. So one last time, it's an undocumented feature. The book says it takes 8 hours to charge from solar. So take it with a grain of salt. So what don't I like about this product? Well, let me tell you something the AUDEW can't do, and that is pass-through. So you can't do the pass-through charging on this, which is a real shame because that is like one of the most used features on portable power stations today. Now, I don't know why they don't offer this feature. It probably has something to do with the fanless silent design and that regulated 15 volts coming in. So something about that combination, they decided not to offer pass-through charging, but they kind of forgot to shut off the jump starter port. So you can technically, like I said, charge this and get power out of the jump starter port, but the cigarette loader port doesn't work, the USB ports don't work, the inverter don't work while you're charging it. So that is a pretty serious limitation. That's definitely the number one thing on my list that I do not like about this product. Now, the other thing I don't like about the AUDEW is the inverter, because what the AUDEW can't do is run anything over 200 watts. And I think the reason for that is pretty obvious. It's this fanless design again. Yeah, you can charge a laptop and some other small AC devices off of this, but don't expect it to brew your coffee or do anything like that. Product price with current discounts. Now, this is where things get pretty serious. The price I'm about to give you is for a very limited time. I'm going to say that again, it's very limited time. If you watch this video a week, a month, or a year from now, don't write me asking for this discount again. You got to be a subscriber and find out about these videos quickly if you want to get these prices. If you're not a subscriber, now is a good time to go ahead and click that subscribe button, because once this price is gone, don't expect it to come back. The current price with discounts for this 300 watt hour lithium iron phosphate portable power station with a 10-year battery is only $217. That's today's price. This is $130 cheaper than the Jackery Explorer 300. This is also $50 cheaper than that Energizer 240 watt hour lithium iron phosphate power station that I just reviewed a few weeks ago. And the AUDEW has more outputs than both of those devices and a longer life than the Jackery and more battery than the Energizer. And you have to remember, this is way cheaper than both of those. So who is this product aimed at? Now this is aimed at buyers who like to keep things forever. If you want to keep a device for a very long time and you're willing to trade things like size and weight for that longevity, and you need a lot of DC output and USB output, this is a fantastic deal. This actually outputs twice as many DC watts out of the Jumpstart port than the Bluetti AC200, which costs $1,700. So put that in perspective. You get this for around 200 bucks, you can put out 600 watts on this port, or you can get the Bluetti AC200 for 1,700 bucks, and that outputs around 300 watts from its 30 amp port. Now again, this is an unofficial feature of this, but I showed you it can be done. And at this price point, there's nothing stopping you from buying several of these, potentially hooking them up in parallel, or charging one while using another. I mean, for 217 bucks, you can pretty much make this a stocking stuffer, assuming that person has really, really big feet. This is also for those of you out there that hate noise. And I know a lot of you out there hate fans, hate computer fans. You won't buy something that's got a fan that never makes noise. Well, this is totally silent 100% of the time. If you're looking for something like that, you don't have like huge power requirements, here you go. This is your opportunity. And to date, this is the only SoGen that I've tested. And yes, I just coined that term right now, SoGen, for solar generator. Write it down, you heard it here first. This is the only SoGen that I've tested on this channel that is totally silent, has no fans, no vents, no openings of any kind for air. Now, how about those of you out there where the AUDEW won't do? Well, in this case, those of you that require pass-through charging, since this doesn't have it. If you require that feature in your SoGen, this is not the SoGen for you. And yes, I'm going to say SoGen at least 2 more times by the end of this video. This is also not for anyone who needs an inverter with more than 200 watts output. Now, it is technically rated at 250 watts, but my own testing, I tried several times to get more than 200 watts out of this. It just wouldn't do it. Your mileage may vary. You might be able to get 250 out of this. It does say on it 250. But what I'm saying is, if you need more than that, this is also not going to be the SoGen for you. You're going to be pretty limited. You're going to be able to run fans and laptops and CPAP machine, electric blankets, pellet smokers, and charge phones and batteries and drones and stuff like that. But you can forget about running any typical kitchen appliances. You're not going to make coffee. You're not going to run a toaster or a microwave. It'll probably run most TVs, but you're not going to probably be able to run like a 70-inch TV or anything like that. Definitely not like a Keurig or a blender. Nothing like that's going to work on an inverter this small. Now, this will absolutely run a 12-volt compressor, fridge, freezer, and run 12-volt CPAP machines, no problem. So what about the recommended solar panel for this? Well, it gets a little tricky because it does say in the book, and it does say on this cable, don't exceed 18 volts. So as long as you get a single solar panel, or you run solar panels in parallel, and you don't exceed, say, 22 volts VOC, you shouldn't have any problems. Now, they recommend a 100-watt panel. You can certainly just plug a single 100-watt solar panel into this, including ones from Jackery and Rock Pals and all the other ones, and it'll work perfectly fine for charging this at probably 60 to 70 watts. If you want to supercharge this, you might want to try getting 2 100-watt solar panels and putting them in parallel, or 1 200-watt solar panel and putting it into the input on this, and maybe you'll get that magic 170 watts that I showed you in my bench test. Recommendations for solar panels are on hobotech.tv/Amazon. Link is in the description below if you're looking for really good deals on solar panels for this or any other power station for that matter. I got the deals there, guys. No point in looking anywhere else. I got all kinds of links and discount codes and stuff on that page. There's a lot of sales coming up because of Black Friday, Cyber Monday, so keep an eye on that page. And hey, you can actually subscribe via email. You can go to the same website, hobotech.tv/blog. There's a little box there. You type your email address in. Anytime I post a video or there's some spectacular sale, you'll get an email. Now, isn't that cool? So if you're interested in the AUDEW Sogen, and I told you I was going to say it twice, links are in the description below with the discount code. Now, there are 2 links below. There's one link that takes you right to the AUDEW website, which is going to get you that $217 price. There's a second link that takes you to Amazon. It's going to be a little more expensive, plus you're probably going to pay tax in most states. So I'm going to suggest you go to their website, get it direct. Again, that price is for a limited time. You watch this video a week, month, year later, that price is gone. This thing's typically $299. So you're getting like 80 something bucks off for watching the HOBOTECH channel. How could you beat that? Thanks for watching. If you learned something today, don't forget to give me a thumbs up below. And if you're not a subscriber already, you know what to do. That's it for now. Till next time.
Odin commands you to like and subscribe, and clean my litter box.
Here we have the first snow of the season on the homestead. There's Mir. No solar today. Yes, I'm kind of like Superman. I wear my special jammies underneath. If you're interested in one of these shirts, hobotech.tv/shop. Let's see how creative you guys can get. Come up with your own AUDEW pun down in the comments. Have fun.
RV Golf Guy, Z Foxfire, Jab Smith.